Welcome back, Algebra fans. This is Mr. Chow Time, interpreting graphs of functions, lesson 8. This one's going to be shorter, I promise. Vocabulary: intercepts. Intercepts are points where a graph intersects an axis. Remember, a graph is the visual representation of a function or equation, and we can put that onto a coordinate plane, and everywhere that this function intersects with the axis, any axis, it's an intercept. So there are y-intercepts and x-intercepts. If we look at a graph, anywhere that it intercepts the y is a y-intercept, and where it intersects with the x are the x-intercepts. For example, we love examples. The graph shows the height y of an object as a function of time x. So here we've launched something into the air. Over time, it increases in height before it comes back down. The y-intercept is right here, which means that when we launched it from not the ground, right? Perhaps like you're standing with a t-shirt cannon and you launch something and then it drops to the ground and it intercepts again with a axis. Since the graph is a curve and not a line, the graph is nonlinear. The graph intersects the y at around 0, 15, so on and so forth. I'll let you pause and look at this if you would like, but basically it just tells you, an approximation of the intercept numbers. The line of symmetry, also called the axis of symmetry, depending on the book you look at. A graph in which a vertical line could be drawn through it, and either side of the line matches exactly. Let's just move on and look at a graph, an example. So you see this here function. It has this line here that goes through the middle of it. And on both sides, if you look at any particular place, both sides you have a point that is equidistant, right? That means that this graph has a axis of symmetry. It also has some roots, also called x-intercept. But depending on also what book you're looking at, it is called a root. When I learned it, it was called roots. It has a minimum here. It's got a vertex. It's got a y-intercept. So many different things going on here. Let's look at some more vocabulary words. A function is positive where the graph lies above the x-axis. So all of this stuff in blue is positive. It's negative where it's below the x-axis, which is right here, x-axis. A function is increasing where the graph goes up from left to right. So here you can see it's moving up. All the rest of it is moving down left and right, which means that these are all decreasing. The points shown are locations of relative high or low values. Relative, that means just looking at the points around it, this is the lowest one. So this one is the relative minimum. If you look at the points around this part, this is the relative maximum. And then the end behavior are at the positive and negative, like the most positive and the most negative values on x. Is it increasing or decreasing? For example, the graph shows the speed of a car after x minutes. Estimate and interpret where the function is positive, negative, increasing and decreasing, x-coordinate of any relative extrema, and the end behavior of the graph. So it's positive between 0 and 7.2, right? So this, I don't know if you've ever seen this notation before, but this is like, this is when a set of values are between two numbers. So x is greater than, right, because the mouth is open towards the x, it's greater than 0. So when we're looking at numbers that are greater than 0, 0 is here, everything on this side of 0. And it's less than, because the mouth is pointing away from the x, 7.2. And so 7.2 is right here. So all of the data from 0 to 7.2, this is the positive stuff. And then negative is anything past 7.2, where it's greater than 7.2. In this particular graph, you could say that it is never negative, and that would be fine. I just want you to know that if you're looking at a situation where there are negative values, then you would just write it like this. Where is it increasing? Well, it's increasing from here to here, and then from here to here, right? It's increasing like that. So it's increasing where it's less than 1. I should delete some of these things. The values that are less than 1 from here to here, and then values from 4 to 6, right? From 4 to 6. The relative extrema, here's a relative extrema, and here's a relative extrema. X equals 1, x equals 6. And you can just draw a line straight down to see what the extrema is. And then the relative minimum, here's another one right here, would be 4. And behavior, as x increases, as we move this way on x, y decreases. That's the edge of the data. As x decreases, y also decreases. So on both of our end behaviors, the y is decreasing. For example, here is a graph of the population of y number of deer. So the y value is the number of deer, and x years. So x is years, y is number of deer on an island. So these deer were introduced, that means they were brought there to the island. Estimate and interpret, where the function is positive, negative, increasing, decreasing, x coordinate of any relative extrema, and the end behavior. Okie dokie. Where is the graph positive? Well, it's positive from here to right here. We'll just say that's, let's say 5.7 or so. So between 0 and 5.7, right? Where x is greater than 0 and less than 5.7. That's where it's positive. And then where is it negative? Well, you could say that it's negative past 5.7, right? So where x is greater than 5.7. Again, here you could say in this particular situation that none of the values are negative because the number of deer is never going to be negative. We're not going to have negative 5 deer, right? So you could also say no negative. And that would be good too. Where is it increasing? So it's increasing from here to here. This is from 1 to, where is that, 4. So it's increasing from 1 to 4 on the x-axis, where it's greater than 1 and less than 4. Where's it decreasing? Well, from this point here on and this point here on, right? And it decreases, potentially it's decreasing like all the way like this, right? So we're just going to say that it's decreasing where x is less than 1 and where x is greater than, what number is this? 4. X coordinate of any relative extrema. Let me erase some of this stuff. Too many things going on here. Okay. X coordinate of any of the relative extrema. So here we have a lowest point, here we have a highest point, right? So for the high X is equal to 4. For the low extrema, X is equal to 1. Okay. Last, we have the end behavior. So as X is increasing, Y is decreasing, and as X is decreasing, Y is increasing. So as X decreases, Y increases, and as X increases, Y decreases. Oh, and I call these high and low, but they're actually also called maximum and minimum extrema. Okay. Only 11 minutes. Goodness. Have a good one. See you in class.